Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on trigonometry degree level chapter Deductions from Moivre's Theorem, lecture number 10, in which I will expand cos theta, sin theta and tan theta in terms of theta. Firstly, we expand cos theta and sin theta in terms of theta. Let n is a positive integer. Therefore, cos phi plus I sin phi whole to the power n equal to cos n phi plus I sin n phi by using De Moivre's theorem. Implies that we write right side in left side, cos n phi plus I sin n phi, and we expand this left side with the help of binomial theorem. This is equal to cos to the power n phi plus n cos to the power n minus 1 phi I sin phi plus n into n minus 1 by factorial to cos to the power n minus 2 phi I sin phi whole square plus n into n minus 1 n minus 2 by factorial theory multiply cos to the power n minus 3 phi multiply I sin phi whole cube plus n into n minus 1 n minus 2 n minus 3 by factorial 4 multiply cos n minus 4 cos to the power n minus 4 phi I sin phi whole to the power 4 plus dot 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 dot. We may write right side as cos to the power n phi plus I multiply n cos to the power n minus 1 phi sin phi. Here I square means minus 1. So we write this as minus n into n minus 1 by factorial to cos to the power n minus 2 phi sin square phi. Here I cube is minus I multiply n into n minus 1 n minus 2 by factorial theory cos to the power n minus 3 phi sin cube phi. Here I to the power 4 is 1, so this is plus n into n minus 1 n minus 2 n minus 3 by factorial 4 multiply cos to the power n minus 4 phi sin to the power 4 phi plus dot 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 dot. Let this is number 1, equating real and imaginary parts of both sides. We get real part in left side is cos n phi equal to, in right side, cos to the power n phi, here minus n into n minus 1 by factorial 2 cos to the power n minus 2 phi sin square phi plus n into n minus 1, n minus 2, n minus 3 by factorial 4 cos to the power n minus 4 phi sin to the power 4 phi plus dot 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 dot. Let this is number 2, and imaginary part, here sin n phi equal to, in right side this is imaginary part, n cos to the power n minus 1 phi sin phi, this is imaginary part, minus n into n minus 1 n minus 2 by factorial 3 cos to the power n minus 3 phi sin cube phi plus dot 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 dot. This is number 3. Let n phi equal to theta implies that n equal to theta by phi. This is number 4. When phi tends to 0, then n tends to infinity, subject to condition that n phi is finite. We know that limit phi tends to 0, sin phi by phi equal to 1 and cos phi equal to 1. Phi tends to 0, then cos phi equal to 1. This is number 5. This is number 6. Using 4 in 2, we get here in 4 n phi equal to theta, so here we write cos theta, and in place of n here we write theta by phi, so we write cos theta left side cos to the power n phi minus, in place of n, theta by phi, theta by phi multiply theta by phi minus 1 by factorial to cos to the power n minus 2 phi sin square phi plus in place of n here we write theta by phi multiply theta by phi minus 1 multiply theta by phi minus 2 multiply theta by phi minus 3 by factorial 4 cos to the power n minus 4 phi sin to the power 4 phi plus dot 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 dot, and right side is cos to the power n phi minus, here we take LCM phi, so here theta minus phi and phi multiply phi square, we write this phi square under sin square phi, so here we get theta minus phi by factorial to cos to the power n minus 2 phi sin phi by phi whole square plus here also in similar manner theta, here theta minus phi, theta minus 2 phi, theta minus 3 phi by factorial 4. Here we have 1, 2, 3, 4 number of phi's, and we will write these phi under sin to the power 4 phi. So here we write cos to the power n minus 4 phi sin phi by phi whole to the power 4 plus dot 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 dot. Let this is number 7 using 5 and 6. In 7 we get left side is cos theta and right side here when phi tends to 0 cos phi equal to 1 minus here 0, this is theta square by factorial 2, here cos phi is 1 sin phi by phi tends to 0, this is 1 plus here phi 0 phi 0 phi 0, here theta multiply theta multiply theta multiply theta to the power 4 by factorial 4, here cos phi is 1 when phi tends to 0 and sin phi by phi is 1 and minus dot 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 dot. This is 8. This is the required formula for expansion of cos theta in terms of theta. Now using 4 in 3, we get sine in phi means theta equal to n means theta by phi cos to the power n minus 1 phi sin phi minus n means theta by phi, again n means theta by phi minus 1, again n equal to theta by phi minus 2 by factorial 3 cos to the power n minus 3 phi sin cube phi plus dot 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 dot, and this will be equal to theta multiply cos to the power n minus 1 phi sin phi by phi minus, here we take LCM, so we will get here theta minus phi by phi, here theta minus 2 phi by phi, here we have number of phi 1, 2, 3, so we write this phi cube under this term sin cube phi, so we write theta minus phi theta minus 2 phi by factorial 3 cos to the power n minus 3 phi multiply sin phi by phi whole cube plus dot 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 dot. This is number 9. Using 5 and 6 in 9, we get in 5 and 6 we have when phi tends to 0 cos phi equal to 1, that is cos to the power n minus 1 phi equal to 1, sin phi by phi is also 1, so remains only theta here. So left side sin theta, right side theta, here also phi equal to 0, phi tends to 0 means here we put phi equal to 0, so remains theta multiply theta multiply theta, theta cube by factorial 3 minus theta cube by factorial 3, here cos to the power n minus 3 phi, when phi tends to 0 cos phi equal to 1, so this will be 1 and sin phi by phi is also 1, so these are 1 plus dot dot dot, since phi tends to 0 implies that cos phi equal to 1 sin phi by phi equal to 1. This is the required formula for the expansion of sin theta in terms of theta. Let this is number 10. Now we expand tan theta in terms of theta, since tan theta equal to sin theta by cos theta and sin theta equal to theta minus theta cube by factorial 3 plus theta to the power 5 by factorial 5 minus dot 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 dot. Here value of cos theta 1 minus theta square by factorial 2 plus theta to the power 4 by factorial 4 minus dot 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 dot. We may write this as theta minus theta cube by factorial 3 plus theta to the power 5 by factorial 5 minus dot 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 dot. Multiply 1 minus theta square by factorial 2 plus theta to the power 4 by factorial 4 minus dot 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 to the power minus 1. We may write this as theta minus theta cube by factorial 3 means 6 plus theta to the power 5 by factorial 5 is 120 minus dot 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 dot. Here we take 1 minus bracket theta square by factorial 2 means 2, here plus and here minus, so here minus theta to the power 4 by factorial 4 is 24 plus dot 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 to the power minus 1. This may be written as theta minus theta cube by 6 plus theta to the power 5 by 120 minus dot 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 dot. Here we use the binomial expansion. So here minus, here minus. So all terms positive. 1 plus 2 theta square by 2 minus theta to the power 4 by 24 plus dot 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 plus theta square by 2 minus theta to the power 4 by 24 plus dot 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 whole square and then theta square by 2 minus theta to the power 4 by 24 plus dot 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 cube plus dot 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 implies that tan theta equal to theta minus theta cube by 6 plus theta to the power 5 by 120 minus dot 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 multiply if we calculate this we will get 1 plus theta square by 2 plus 5 by 24 theta to the power 4 plus dot 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 this, and after calculating this we may write tan theta left side equal to theta plus theta cube by 3 plus 2 by 15 theta to the power 5 plus dot 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 dot. This is the required formula for expansion of tan theta in terms of theta. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.